Bismillah.
So ya shabab, last time we said that. What do we mean by equilibrium position? It's the position where we have net force of 0. Yes? So let's do an example. So find the equilibrium position given the following. Let's say that we are given those two charges with this separation distance. One of them is positive. Let's say the first one is 4 nanocoulombs and the other one is negative. Let's say that it's minus 1 nanocoulombs or minus 2 nanocoulombs. Let's call this one as Q2. Let's call this one as Q1. Now, based on what we said last time, ya shabab, we said that if one of them is positive, one of them is negative, where is the equilibrium position?
Between them.
No, outside, between them if they have the same sign. So let's remember this before we continue. If they have the same sign, the equilibrium position will be somewhere in between. If they have opposite signs, the equilibrium position will be outside and closer to the smaller magnitude. So here, let's say this is 4, this is 1, it's here closer to the smaller. Let's say that this is minus 4 nanocoulombs, this is 1 nanocoulombs, so it would be outside here and closer to this one. Equilibrium position, rule case number 2, we said that if one of them positive, one of them is negative, it will be outside. Let me prove that. So let's say that this is positive test charge, so it is repelled by this one, it is attracted by that one. You see, both forces are in opposite directions. Here it is repelled by this and also repelled by this. This is why it's in the middle. This is why it's outside.
That's closer to the
Yes.
most.
So here, ya shabab, we know that the equilibrium position will be outside. So let's say that the distance between them is 5 centimeters. So we know that the equilibrium position, ya Badr, will be somewhere outside.
Yes.
Let's call this distance as x, and this is the equilibrium position. So let's assume we have a small test charge of magnitude q. Now, in the exam, I won't give you the charge and you don't need it because it will be cancelled from the equation. We're gonna see now how. So what's the net force on this charge q? Let's call it q3. So it is attracted by q2. This is force 2, 3. And it is repelled by q1. In order to have equilibrium, we say that the net force should be 0, meaning that force of 1, 3 should be equal to force of 2, 3. So we say force 1, 3 is equal to force 2, 3. So okay, Q1, Q3 over, what's the distance between 1 and 3?
5 centimeters.
It's 5 centimeters plus x
X,
in order to reach this. So it will be 5 centimeters, 0.05 plus x, all of it squared. I already changed. The other distance, so k, q2, q3 over, what's the distance between 2 and 3? X over x squared. What is cancelled? K is cancelled from both sides. Q3 is cancelled, so I don't really need actually the magnitude of the charge. So in the exam, if I give you this without the magnitude of the charge, you can assume it as 1 and cancel it at the end. So it would be Q1 over this is equal to Q2 over this. So let's replace the values. What's the value of Q1? 4 nanocoulombs, which is 4 times 10 power minus 9 divided by 0.05 plus x, all of it squared, is equal to Q2, which is 2 nanocoulombs, so 2 times 10 power minus 9 over x squared. What is cancelled?
10 times negative 9.
So you see, ya shabab, if they have the same power value, we can cancel. Opposite powers, we don't cancel. Now what do we do, ya shabab? We want to get rid of the squared. So we do, now before we cross product, let's make it easier. I don't want the quadratic function, so square root both sides. After square rooting both sides, what's the square root of 4?
2.
2 over خلاص here the squared and square root they cancel out each other, so it would be 0.05 plus x. All of this is equal to the following. Other side, what's the square root of 2?
I think.
1.41, I think.
No.
Wallahi, make sure, yes please, make sure. I think 1.41
Correct.
over x. Now we cross multiply, Ali. Now we cross multiply. So 2x is equal to 1.41 times 0.05. How much is it? 5% of this.
0.07.
0.07 7 or something. 0.07.
Yes.
Okay, plus
1.
1.41x. What do? We take this to the other side, so it will be 2x minus 1.41x is equal to 0.07. 0.59x is equal to 0.07. Divide both sides by 0.59 because you want to get x only, not 0.59 of x. How much is it, Suhail?
Yes, teacher.
0.07 over 0.59. How much is it?
0.11.
0.11?
Yes.
So what does it mean when we find that 0.11? That the distance between Q2 to Q3 is 0.11?
Yes.
What's the unit?
Meter.
Meters, because we already changed from centimeters to meters. So it should be 11 centimeters. Let's do another example when they are both negative.
أستاذ نكتب سنتي ولا متر أحسن في الفوق أكتب فوق.
عادي, if you want to write 0.11 meters, you can. If you want to write 11 centimeters, you can. Okay? Another example. Yeah, that's it. Another example, and let's do it using the shortcut method without doing all of this. So how do we do it,
Me.
Badr Rami? So let's say that both are negative.
Yes.
So let's make this one as minus 4 nanocoulombs. I'll use the same magnitudes, and the other one is minus 2
This new
nanocoulombs,
example.
separated by 5 centimeters. Now, you choose one position, you call it as x, and the remaining position you want to call it as y. So let's say that this is x from here to here,
The rest is y.
and the remaining one is y.
They will
So what's the relationship between x and y?
attract? They'll go towards each other.
X and y are distances. If you add distance x to distance y, you get the 5 centimeters. But how did I know that the equilibrium is somewhere in the middle?
Because they
Negative
have,
and negative.
They have the same sign. So we say that
Try to catch.
خلاص كده. So x plus y is equal to 5 centimeters. Which means that y in terms of x, so you write one of them in terms of the other. So y in terms of x is equal to 5 centimeters minus x, or 5 minus x centimeters. So let's call this as Q3 in the middle. This is Q1. This is Q2. So to find equilibrium position, we do the following. We say, okay, what are the forces acting on Q3? It's attracted by Q2 and it's attracted by Q1. So we have two opposite forces. So we say that force between 1 and 3 should be equal to force between 2 and 3. So K, Q1, Q3 over, what's the distance between 1 and 3? Y, which is 5 minus x centimeters, or 0.05 minus x squared.
Y squared.
Coulomb's law, K, Q1, Q2 over distance between them squared, is equal to K, Q2 Q3 over what's the distance between 2 and 3? X over x squared. What is cancelled? Same thing.
Q3
3
Q3
and K.
K.
and K. Why are they cancelled?
because we don't need
It's on
magnitude.
both sides.
Yeah, come on.
What's Q1? So 4 times 10 power minus 9 divided by 0.05 minus x all of it squared
Squared.
is equal to Q2, which is 2 times 10 power minus 9
Over x squared.
over x squared. We want to get rid of the squared. What do we do? Square root. While doing the square root, we also cancel times 10 power minus 9. So square root both sides. Square root of 4, which is 2, over 0.05 minus x is equal to square root of 2, which is 1.41 over x. So we have 2x cross multiply. 2x is equal to 1.41 times 0.05, which is 0.07, minus 1.41x. Move this to the other side, so it would be 3.41x is equal to 0.07. Divide 0.07 by 3.41.
0.02.
What's the unit? 0.02, because we changed it from centimeters to meters. Or we can just say that it is 2 centimeters away from this one. Can we do this in less steps? Yes, we can. This is how, ya shabab. So how do you do this, ya Bakr? You take the magnitude of the first one, which is 4 nanocoulombs. You take it like this, 4, over the distance from it to the charge. What's the distance from it to the charge? 5 minus x. You can remove all the units. If they have the same units, you can just remove it. So 5 minus x squared equals, you take the magnitude of the second one, which is 2, over distance between it and the charge, which is x squared. What do you do? Square root.
أستاذ
Yes.
متى نعرف إذا 5 minus x ولا 5 plus x؟
If the point is in the middle, it will be 5 minus x. If it's outside, it will be 5 plus x to reach it. And after solving this, you get that x is equal to 2, which is in our case 2 centimeters, since I didn't change the units. Why did I write it like this directly? Because k is cancelled, q3 is cancelled from both sides. We only have q1 over this, and we have q2 over this. Okay? Is this clear, ya shabab?
Yes.
It's done.